What I'm going to be able to explain to you in less than 10 minutes
I like you, man. You lie a lot.
is going to make you more knowledgeable than 99% of people in the pickleball industry about how paddles are tested and certified. So let's get into it. Want to give a brief acknowledgement here. First and foremost, a huge shout out to USA Pickleball, in particular Mike Neely, John Anderson, and Carl Schmitz, as well as Element Space Labs, for allowing me to come out to Baltimore and experience the current state of the paddle testing. It was a hugely insightful process. And outside of my explanation of the tests, the extent of my analysis is going to be limited to a little bit about why they're relevant and just some potential areas of improvement that arose during Media Day. I'm not going to get super hung up on the technical methodology or proof of concepts, i.e. why these tests are accepted and valid the way they are. USAP clearly has very smart individuals working for them that have the sole focus of making the game fair for everyone. Where I think the issues really come in are with enforcement of the rules from USAP, which inherently impacts adherence to the rules by companies and manufacturers. So I think everybody at USAP would agree that clarity and enforcement of the rules is going to be the major key to preventing these sudden delistings we've been experiencing, as there's very little that's glaringly obvious that's wrong with the actual testing process. All that to say, it's not super relevant for you to know that the paddles are kept for 24 hours in a room temperature controlled to 70 degrees Fahrenheit plus or minus 10% humidity before being tested. That is nerd shit. If you guys want me to cover that stuff, I'm happy to. Let me know down in the comments if you want to see that later. But for now, let's talk the 6 tests that USAP is currently running and the one that's on the horizon, from least complicated to most complicated. The first test is a size measurement. USAP guidelines state that paddles can't be any longer than 17 inches, and the combination of length and width cannot be more than 24 inches. They measure this by taking a chamber about 10 cubic feet in size, placing the paddle in the center, and then heating that chamber to around 90 degrees Fahrenheit with 5 megapascals of pressure, and then I'm messing with y'all. 5 megapascals of pressure at that temperature would easily be enough to crush human bones and render every single nerve ending in your body completely useless. They basically just take a fancy digital ruler and measure the paddle accordingly. Don't overcomplicate it. This limit is necessary, of course, because otherwise we'd have people with tennis racket size paddles playing on the courts, which would make no sense. The next test I'll explain is a gloss or reflection test. Essentially, 3 parts of every paddle are sampled, whether it's on the face, on the edge guard, or elsewhere, and when put through this test per the guidelines, no area can exceed 80 gloss units in value. In layman's terms, when a light is shined on the 3 tested parts of the paddle, a machine measures the intensity of the reflection at a predetermined angle, and the intensity of that reflection can't surpass what roughly equates to shining a light on a fresh granite or marble kitchen countertop finish. The rule is in place, of course, so that all players can keep track of the ball at all times. Most play happens outside, potentially in sunlight, and players already complain about the video boards behind courts being too bright. So imagine if we had super reflective paddles and clothes, they would riot. The third test we'll look at is the coefficient of friction test. Essentially, a block of Delrin-based plastic is pulled 3 times per side across the center of the paddle, starting at the throat and finishing at the top, and the load required to pull this block, which is about 8 pounds, needs to be lower than 18.75 pounds, equating to a coefficient of friction of 0.1875. All in all, a piece of plastic that really roughly mimics ball material, as well as how the ball sinks into the face on a normal hit, is dragged across the paddle face to make sure that it's not using too much stickiness to grab and spin the ball. All in all, a coefficient of 0.19 is actually very low. To go back to the kitchen example, it's like pulling a plastic cutting board across a smooth stone finish counter. Here we're dealing very closely with the tech that Proton uses in their Type A paddle faces. And the reason why this is monitored so closely is because other than making grit super high in order to grab the ball, making the ball stick to the paddle face is the primary other way to generate super high levels of spin. So this prevents the use of table tennis rubbers, pine tar, etc. that'll make the ball too easy to spin. Just based on what I've seen, some potential improvements here could be making the material a little bit more close to replicating an actual pickleball surface, as well as performing the test in multiple directions the way that surface roughness is measured. Speaking of surface roughness, let's talk about that test next. This is where we bump things up a little bit. On site, you're using a Start SR160, but in the lab, they're now using an optical profilometer, which creates a 3D profile of the grit in the center of the paddle in 6 different directions. And in each of those directions, the RT value cannot exceed 40 micrometers, and the RZ value cannot exceed 30 micrometers. And failing either of those directions fails the paddle. Basically, USAP is taking a really fancy microscope to look at the peaks and the valleys of the grit, which for all intents and purposes looks like those egg carton mattress toppers. And they essentially say in the 6 directions we're measuring, the highest peak and highest valley need to be below a certain limit, 40 micrometers, and the average of all the peaks and valleys we're measuring needs to be under a limit as well, 30 micrometers. These values are important because USAP determined that grit that is higher than these levels unfairly grabs and hooks the ball to give it too much spin. And it's important that they fail the paddle in any one direction because companies in the past have tried to circumvent this rule by creating super high grit in one direction and averaging it with super low grit in another direction. Cool, still not too bad. Now let's get to test 5, which is the deflection test. This is an interesting one. So a paddle is placed overlapping 2 metal bars, everything running in parallel. And then a machine with a 1-inch diameter metal tip applies a 5-pound preload to the center point between the 2 bars, after which an extra protrusion extends until a total load of 6.614 pounds is reached. And the displacement of the paddle face cannot exceed 0.005 inches. And this needs to be measured across 3 different points, which cannot be within 1 inch of each other, plus or minus 0.25 inches. In other words, a machine presses into a paddle face at 3 different points to make sure that it can't press in too far, which would create an unfair spring or trampoline-like effect of the ball off the face. One question I didn't quite get to ask is why there's a load difference between this test, for example, and the coefficient of friction test. They're both attempting to replicate real-world scenarios as best they can with static paddles, and yet there's a difference here that's a little bit confusing. And the biggest issue with this test is that isolating the points of testing completely ignores the impact that the rest of the paddle face movement from wall to wall has on the deflection of the ball at that point, which makes it a flawed test for power. Which is why it's currently being used in tandem with our 6th and final test that we'll be discussing that's been implemented by USAP, the PBCoR test. This is our most complicated test by far, so stay with me here. The PBCoR test, or paddle ball coefficient of restitution test, is, as the name implies, a coefficient test that measures ball energy absorption by the paddle. USAP conducts this test as follows. A cannon launches a holeless pickleball, knuckles it rather, at 60 miles per hour at the determined sweet spot on the paddle face. The paddle is held in place by a contraption that clamps it 5 centimeters above the end cap and allows the paddle to recoil after the impact, similar to how it would in a real-world scenario. This box contains lasers, which not only allow us to determine if the inbound and exit direction of the ball was linear, but also measures the inbound and exit velocity of the ball, which is ultimately used to create our coefficient of restitution. So what's happening here is the cannon is launching a pickleball with no holes into the sweet spot of the paddle, which ideally should be the most reactive part of the face. And then the lasers measure how fast the ball goes into the face and how fast it comes off in order to create a ratio, which needs to be less than 0.43, meaning most of the ball energy is absorbed by the paddle. And the paddle is clamped roughly where your hand should go, and then is allowed to recoil because, again, in the real world, your paddle is never staying 100% in place when receiving a ball at that level of speed. There are 2 things that I don't think were completely thought through, and this first one was a major point of contention on Media Day, which is the pressure applied to the clamp on the grip. USAP does remove the stock grip because of its shock absorption capabilities, but if the pressure is too high, the paddle becomes a lot stiffer and might cause the ball to exit a lot faster, and vice versa if it's not clamped hard enough. And the actual pressure that is being used to clamp the paddles at this time was not something that USAP gave a super straightforward answer on. And the second thing is, while using holeless balls was very smart, and they also don't allow balls to be used more than 30 times, they don't actually measure which part of the ball is striking the paddle every time. So theoretically, the ball could still deform because it's striking the same part of the paddle 15 times and they would never know. Now that's a pretty unlikely scenario, but it's not impossible. Where this ties in with the recent delistings is you can imagine with Gen 3 paddles in particular, as they break in over time, they react differently to this test, allowing the ball to exit off with higher speeds. Right now, USAP is adamant that all paddles throughout their entire life cycle must stay under this 0.43 ratio. And they do have a top 10% performers rule implemented, where the top 10% of performers in PBCoR are given a full teardown in order to verify the internal structure against what the manufacturers have provided. What became a super contentious point and dominated the conversation on Media Day was whether or not USAP should be holding companies liable for staying under the 0.43 ratio down the line, considering all testing occurs with brand new paddles. And furthermore, if there should be a penalty assessed on companies that are discovered to be breaking the rules so that they are not incentivized to make sure that the paddle passes the tests and then breaks in to go out of spec over time. All right, so that pretty much takes care of all the testing that USAP is currently doing. Now, the one test that is on the horizon that we were told about during Media Day is actual spin testing. USAP will clamp a paddle at a 45-degree angle and shoot a ball at 45 miles per hour in order to measure the resulting spin using high-speed cameras that can account for ball translation and paddle rotation upon the impact. In a nutshell, USAP is again going to rocket a ball at a paddle face and then use a high-speed camera to capture the actual spin rate. And the camera will also make sure that the paddle doesn't rotate too much and that the ball doesn't slide too much on the paddle face, both of which would create inaccurate numbers. It's hard to get into the details of criticism on this one because the test isn't implemented yet, but we are definitely going to need to see documentation again about that clamp pressure and of course how that camera is allowing USAP to make sure that the collision of the ball on the face allows it to reach its maximum spin potential. If you made it here to the end of the video, just know that you are now 40% smarter and 60% more handsome and or beautiful. Thank you so much for watching and for your support. Make sure you like, subscribe, comment down below any thoughts you have on this process. And again, if you want me to cover this in a more detailed scientific approach in the future. And with that, I hope you all stay happy and healthy. And of course, out on the courts. Until the next video. Peace.